right, here is Unit 6, Lesson 2. This is covering Chapter 6.2 in the textbook. We're still on systems of equations. All right, so we're going to learn a different way to solve systems, and that is by what we call substitution. Okay, so here are the steps. I got these from the book. I'm going to obviously walk you through these steps and what exactly they mean. So remember last lesson we learned how to graph them, and that works great in a lot of scenarios, but a lot of times the solution may not be a whole number. So your solution could be 3.1 comma 5.5. Okay, that's going to be hard to identify by graphing. But if we substitute, we can actually find the numerical answer very easily. So step 1 says solve for one variable in at least one equation, if necessary. Okay, so we need to have a variable isolated. Now that variable does not have to be y, although in a lot of cases we think we want to solve for y. Then we're going to substitute the expression into the other equation and we're going to solve yada yada. You can come back to these steps and look at them. I'm going to show you what it means in practice, and then maybe you can go back and read the steps and think about what we did. All right, so here's an example. This one's really easy because why? Because the y's are already isolated, okay? So here's what I want you to think about. This y equals 2x, and this y equals x plus 5. Now, if you think about if we were to graph these, we're trying to figure out where they cross, okay? So if we're trying to figure out where they cross, then we're trying to figure out where they have the same value. So I am going to set these equal to each other. If this is y and so is this, then what does that mean? That means that 2x should equal x plus 5, right? Okay, these should be equal because I want the y values to be the same. I also want the x values to be the same. So now I'm just going to solve for x. I'm going to subtract x from here. This is so easy. 2x minus x is x equals 5. Okay, so that's the x value. But again, I need an ordered pair. I need an x value and a y value. This is not my solution. This is only part of my solution. So now I need to pick one of these equations. I can use either because it should work for both. I can pick one of these and I can substitute 5 for x and solve for y. Again, very easy. If y equals 2x, then that means y equals 2 times 5 and y equals 10. So what is my solution? My solution is 5, 10. That is where these two lines would intersect. That is the solution to this system. And that is by substitution. How? Because we substituted, this is what we did. We substituted this 2x in for this y. That's what we did. Because why? Because this is equal to y, so I can take this and I can put it here and solve for x that way. Notice when we had this equation, we only have one variable now. We just have x. We don't have x and y. That's the whole point, is that we need to get it to where we only have one variable and we can solve. All right, let's look at a different example. Now in this example, this y is by itself. This one is not, but you only have to have one variable isolated. So this will work. So what's going to happen is I am going to substitute this x minus 4 in for that y. That's what's going to happen here. So 2x plus what? Well, I'm substituting this for y. So plus x minus 4, and if you want, you can put that in parentheses. It's probably a good idea, equals 5. So again, what did I do? I substituted this in for where the y was. Instead of putting a y, I put what equals y. What equals y? X minus 4. Now I'm going to solve this algebraically. Again, I just have x. So 2, what the heck? I don't want a crown. It's cute and all, but all right, so 2x plus, now this is a positive, so that means this doesn't change. If this was a negative, then the signs would change. So I'm just going to take the parentheses out. Plus x minus 4 equals 5. Well, I can combine the 2x and the x into 3x. Oh, nope, minus 4, not plus 4. 3x minus 4 equals 5. Add 4 to both sides. This is why solving equations is so important. 3x equals 9. X equals 3, because I divide by 3 on both sides. So again, that's only part of your solution. So my solution is going to be 3 comma something. What is the something? Well, all I have to do now is plug the 3 back into one of these equations. Now think about which one would be easiest. If I plug in a 3 here, I'm going to have to move this to the other side still to find y. If I plug it in here, I don't have to move anything. I just have to do the math. So that's what I'm going to do. Y equals 3 minus 4, which is negative 1. So that is my solution, 3 comma negative 1. All right, so we're just substituting, but we have to have a variable isolated in one of the equations. In our first example, we had both y's isolated. So we just put this equal to that because we substituted them in here. In this example, we have the x minus 4 is y, so we took him and replaced him for the y in the first equation. Okay, notice I did not have a variable isolated here, and that's fine. All right, in the next example, I'm going to erase this. All right. So in this example, I don't have any variable isolated. I've got 4y minus 5x equals 9 and x minus 4y equals 11. So I need to figure out what variable I want to isolate. Do I want to isolate this y, this x, or this y? All right, so think about this. The easiest one to do should be the one that has a coefficient of a 1. Okay, what's the coefficient of this y? It's 4. That's not good. The coefficient of this x is a negative 5. That's going to be kind of hard too. The coefficient of this x is a 1. Okay, so that's a good idea. The coefficient of this y is a negative 4. Probably not a good idea. So this looks like our best bet. So how do I get x by itself? Well, I add 4y to both sides. So x equals 11 plus 4y. Okay, so I just isolated the variable. Again, you do not have to isolate the y. Isolate what's going to be easiest, and that should be the variable with a coefficient of a 1. So now what am I going to do? I'm going to substitute. So I'm going to substitute the 11 plus 4y in for what? Well, it equals x. So I have to substitute it in for that x. So let's see what that looks like. So 4y, I'm going to do a different color. Let's do blue. 4y minus 5. Now this is where I'm substituting. Okay, in here I'm substituting my 11 plus my 4y. Okay, that was from this. This equals x, so I'm substituting it here for x. Equals 9. So now I need to distribute. So 4y minus 55 minus 20y equals 9. Now I need to combine like terms. These are on the same side. So 4 minus 20 is negative 16y minus 55 equals 9. All right, so I'm still trying to solve for y. This is back to my solving equation. So I need to add 55 on both sides. So negative 16y equals 9 plus 55 is 64. Now I need to divide by negative 16. So y is equal to negative 4. 64 divided by 16 is 4. Because 16 times 2 is 32. Double it, you get 64. Okay, so again, this is only part of my answer. And notice what variable you're solving for. This is really important. Okay, this is not x, this is y. So my solution, I'll write it over here, my solution is going to be something comma negative 4. So now I need to figure out what my x is going to be. Well, don't I know that x is equal to 11 plus 4y? Well, I sure do. Now, remember, this is the same as this right here. It's just written differently. So you could plug this negative 4 into this y, or this y, or this y. I'm just choosing this because it's the easiest because the x is already by itself. So x equals 11 plus 4 times y, which is negative 4. So x equals 11 minus 16. 4 times negative 4 is negative 16. So x equals negative 5. So my solution is negative 5, negative 4. So that is how you solve by substituting. Now you need to recognize, now that you know how to graph them and how to substitute, you need to recognize which one would be easier, okay? Most of the time, I'm not going to tell you which one you have to use. You get to decide. So if they're both, like in the first example that we did here, let me go, let's see. In the first example, they were both in y equals. Honestly, that would probably be easier to graph. Okay, but some of you don't like graphing, so maybe you want to substitute. That's what you need to start to recognize. Okay? All right, so well, we'll do these we'll get to those in just a second. Okay, so you want to try to recognize which method is going to be easiest to solve with. All right, so let's look at these next examples. All right, so here we have negative 2x plus y equals 8, 3x plus 2y equals 9. Okay, so if we're going to solve by substitution, we have to have a variable isolated. So I want to look for a variable that has a coefficient of a 1. This y has a coefficient of a 1, so I want to solve for y. How do I solve for y? I add 2x to both sides. So y equals 8 plus 2x. Okay? I just solve for y in this equation. So now what am I going to do? I'm going to substitute this in for y right here. Okay, I'm going to substitute this in for y in the other equation. I don't want to substitute it in here. That's not going to help me. All right. So let me see my pen. All right, so 3x plus 2 times, this is what I'm substituting, 8 plus 2x equals 9. So now I'm going to distribute. So 3x plus 16 plus 4x equals 9. Combine like terms, I get 7x plus 16 equals 9. Subtract 16 on both sides. 7x equals negative 7. Divide by 7. Is that right? Divide by 7. X equals negative 1. 9 minus 16. Yeah, okay. All right, so x is negative 1. So my solution is going to be negative 1 comma something. So now I need to plug in the negative 1 for x in this equation, right? Because I already have my y by itself. So y equals 8 plus 2 times negative 1. So y equals 8 minus 2, because 2 times negative 1 is negative 2, so y equals 6. So your answer is negative 1 comma 6. Remember, you can plug this back into here to both of these and see if it works. So negative 2 times negative 1 is 2, plus 6, y is 6 is 8, so that works. 3 times negative 1 is negative 3, plus 2 times 6 is 12. Negative 3 plus 12 is 9, so it works. All right, so we have to get a variable by itself and then substitute that expression in for that variable on the other equation. So I'm going to erase this. All right. Okay, y equals negative 2x plus 5, and 2x plus y equals 1. Oh, I already have a y by itself. That's easy. So I'm going to substitute this negative 2x plus 5 in for this y. So here we go. All right, so 2x plus negative 2x plus 5 equals 1. Just substituted it in. Now remember, these parentheses don't matter because this is addition, so it's not going to change. So 2x minus 2x plus 5 equals 1. When I combine these like terms, 2x minus 2x, I get 0x. 0x is not x. It's nothing. Okay, if you want to write 0x, that's fine, but you need to understand that 0x is literally nothing. So this is the same as 5 equals 1. Does 5 equal 1? No, it does not. So what does that mean? That means that this is no solution. So when you are solving by substitution, if the variable disappears, you get 0x somewhere, okay, on one side or the other, and you end up with an equation that is not true, 5 does not equal 1, then there's no solution. All right, let's look at this last one. So I need to solve for a variable, okay? I probably don't want to solve for this x. I don't want to solve for that x. I don't want to solve for that y. I'm going to solve for this y. How do I do that? I add 2x to both sides. So y equals 1 plus 2x. What am I going to do with that? I'm going to substitute this in for this y. All right. So 6x minus 3 times 1 plus 2x equals negative 3. Distribute 6x minus 3 minus 6x equals negative 3. 6x minus 6x is 0x. So those cancel. So what do I have? I have negative 3 equals negative 3. Is that true? Yes, it is true. So that means that this is infinitely many solutions. Okay? So again, the variable canceled out, but this is a true statement, so it's infinitely many. What does that mean? That means that these two equations are the exact same equation. Remember when we graphed them, they were the exact same line. Whereas this one, these are going to be parallel lines. When there's no solution, that means they're parallel lines. These have the same slope. Okay, think about it. If I subtract 2x on this side, then I'm going to get a negative 2x just like this one. Okay, so that's what it's going to look like for no solution and infinitely many when you're solving by substitution. I just wanted you to see and know to be able to look for that. All right, review any parts that you didn't understand, and I'll see you in class.